Okay, we are looking at making this a fairly short lesson. This is all using the calculator on your to find trig values. So you're going to find angle measures using a calculator, and then you're going to find angles using reciprocal trig identities. So that's going to be the new one, is the reciprocal trig identities. So notes 2.3, finding trig function values using a calculator. So on your calculator, the first thing you have to do is make sure you're in degree mode. So when using the calculator, please verify this. Press the mode button. That's up there by the second button. Just highlight, go down, highlight degree, hit enter, and then get out of there. Also, don't forget your reciprocal identities. We have sine is the reciprocal of cosecant, cosine is reciprocal of secant, and so on and so forth. Try not to use that 1 over cosecant when you're doing things, because that's just making your problems harder. Reciprocal, take the reciprocal, simply flip the fraction over. Okay, so the first problems are asking you, when given the angle theta and you are finding the value of function, use the sine, cosine, and tangent buttons on the calculators. These are one row above the actual numbers. So on this one, it says use a calculator to find the decimal approximation for each value. Give as many digits as your calculator displays. You don't have to worry about what quadrant you're in or anything else. You simply have to go in. So this one being cosine. Now, if you have it inspired, it has all of those trig functions on there for you, so you can just press it and go. If you have the 84, not always will that work so nicely for you. But this one, you're going to put it into the calculator exactly like this. But this is where I get to tell you where to find the degree and minute symbols. So degree and minute, you're going to do a second, and then it's the apps button. And your degree symbol is the very first one. For minute, it is second, app, and it's your second button. So now that, or you can change this into a decimal value, it doesn't matter. But if we throw this straight into the calculator, we get 0.4771587,603. And that is our cosine value. There is no math to be shown. This is really just testing whether or not you know how to put something into a calculator. Okay, so the second one, cotangent. Now, cotangent is not one of the buttons that we have on our calculator. However, again, if you have the Inspire, it does have cotangent, so you're lucky you're going to just plug it in. So, but cotangent, we get to go through and go, oh, reciprocal is tangent. So what you're going to do is you're going to put it in as tangent, parentheses, you're going to do tangent of negative 512 degrees, 20 minutes, close your parentheses, to the -1 power. This button is right above the x squared button, or right next to the sine button. So your x to the -1 on button on the calculator is going to do exactly that. It's going to do the reciprocal. So again, since cotangent is reciprocal of tangent, and tangent's a button on our calculator, we do tangent and take the reciprocal and we get our answer. So if we do that one, our value will be 1.907414744. Okay, and then our last one here is sine of 33 over cosine of 33. Since these two angles are exactly the same, sine over cosine equals tangent of 33. Now, you can put it in as sine of 33 over cosine of 33 if you want, or you can simply put it in as tangent of 33. And when you do that, you get 0.6494 0.75932. There's nothing more to it than that, but knowing how to work your calculator. Okay, so now what we go into is, what if I know my trig function value, but I don't know the angle? So when given the function value and you are finding the angle theta, use the sine of arc. This is called arc sine, arc cosine, and arc tangent. This is the symbols. You can see these problems written either way, so be really, really cautious on those. So the very, very first one is asking you to find a tangent of theta. So these are inverse functions for sine, cosine, and tangent. Inverse undoes what had already been done. So you would write this as the arc tangent of the tangent of theta equals the arc tangent of 6.4358841. And what happens is they're inverse functions, so they actually cancel each other out. And so this is gone, and you get theta equals all of this. And then you're going to plug this into the calculator by doing a second tan. And then that should give you the arc tangent. When you do that on this one, you'll get 81.168073334 degrees. Don't forget your degree symbol. So theta equals. Okay. Now again, here we have a cosecant. If you have an Inspire, the arc cosecant is on there, but our 84s do not have that. So what we're still going to go through going, okay, so this is arc cosecant of the cosecant of theta equals the arc cosecant of 1.3861147. Again, these two will cancel each other out, and you're left with theta. Now here's the problem on this one, is cosecant's not on our calculator, but the reciprocal is sine. So we're going to, the whole thing in, no, we're going to do the parentheses, so we're going to go sine, arc sine, this value, 1.3861147, but this is what I want it to be the reciprocal of. So I'm going to reciprocal of that and then close your parentheses. When you put that in, you're going to get theta equals 46.17358.205. And don't forget your degree symbol. Okay, we may have to talk about these. I think the sine, cosine, tangent ones, you'll be going, yep, got this. It's going to be the cosecant, secant, and cotangent that I have to make sure that you guys have down. So we'll spend a little bit of time in class doing those. Okay, so let's apply this a little bit, both of these ideas. Okay, use a calculator, throw all of this into the calculator, and find the answers. So you'll have to pause. You're going to punch it in because there's nothing for me to show. But you will get an answer of 0 on this one. There it is, answer of 0. Now my question for you is, how does this happen? I have cosine of 75 times cosine of 14 minus sine of 75 times sine of 14. And let me give you a hint on these. It's called cosine functions. And we'll talk about that in class later. Okay, the next problem, they're asking you to use a calculator to decide whether the statement is true or false. There they are using that cotangent again. So when you throw this in the calculator, you're going to do 1 plus parentheses tangent of 42.5 close parentheses twice. We need it squared, but we also need the reciprocal, so you're going to raise it to the negative 2 power. And you'll throw this into the calculator, and you will get now you're throwing the whole thing in, 2.19095425. Now we also have to do the cosecant side, which is sine. Reciprocal of cosecant is sine. 42.5 degrees. But I need to now square that value and take the reciprocal. So we want that to be to the negative 2 power. Now you can do these separately. You can square it and then take the reciprocal, or you can take the reciprocal and then square. Or you can just simply do it to the negative 2 power and get it both done at the same time. When I throw that in the calculator, I get 2.19095425. So therefore this is a true statement. You get plenty of those in your homework. Okay, so last idea. Finding grade resistance. Get a little physics going on with this one problem, but anybody who's gone up to NAU, to Flagstaff, and you always see that, this is the downhill grade. They're showing you how much gravity resistance is put on your car when you're doing this. So when an automobile travels uphill or downhill on a highway, it experiences a force due to gravity. The force F in pounds is called grade resistance, and is modeled by the equation force equals the weight of the car times sine of theta. So theta is the grade, W is the weight of your car. So if you're going uphill, it will be a positive value, or theta will be a positive value. And if you're going downhill, theta will be a negative value. So the very first problem says, what is the grade resistance of a 2,400-pound car traveling on a negative 2.4% downhill grade? So we go on there going, okay, well, my function is F equals W times sine of theta. So F equals 2,400 sine of negative 2.4. Throw that lovely thing into the calculator and you get F equals negative 100.501569. Now the value is negative because you're going downhill, so there's really no gravity resistance. Gravity is actually pushing you down, so the car is feeling a little bit lighter and you're able to move a little bit faster. We know how that goes, unless you don't know how to drive or haven't driven on a big hill. Last question here is the last question. Which is greater grade resistance, a 2,200-pound car on a 2% uphill grade, or a 2,000-pound car on a 2.2% uphill grade? Let you guys think about which one do you think is going to be. You might want to pause it, go ahead and calculate, and see if you get the right answer. Okay, so we're going to just do these side by side. Sine of 2.2. Though in the calculator, this one gives me 76.77. And this one gives me F equals 76.77. Now I've only done it to 2 decimal places, but they're exactly the same. So we've got to look at something beyond that. So after 77, this one is 889. And this one is 5.6. I think we can see that 5 is a little bit smaller than 8, so this one has the greater resistance. Not by a whole lot, but we can also see the pound of the car can give you the same grade resistance on a smaller slope than a lighter car on a bigger slope. So, so there's more than one factor involved in there. So there you guys go. That is the end of this one. And the last page has got your homework on it. There it is. Ooh, okay, you guys are excited, I know. All right, so we'll look at these things tomorrow.